Imagine this, you type a simple prompt, hit generate, and boom, a professional AI-generated video appears in seconds. Sounds like magic? Well, buckle up because in the next 30 minutes, you're going to build exactly that. This isn't some toy project, we're building a real AI video generator that could actually go viral. Ready to blow some minds? Here's what makes this project insane. We're combining OpenAI's GPT-4 for script writing with DID's video generation API. The result? You input a topic, AI writes the script, generates a video with an AI avatar, and delivers it ready to share. This is the exact tech stack creators are using to pump out content at scale. And yes, some people are making serious money with this. What you'll need. Before we dive in, let's make sure you have everything ready. You'll need Node.js installed, a code editor like VS Code, an OpenAI API key, a DID API key, and basic knowledge of React and JavaScript. Don't worry if you're not an expert, I'll guide you through every step. Let's start by setting up our project structure. Open your terminal and create a new directory. We'll use Vite for our React frontend because it's lightning fast, and we'll set up a separate Express backend for our API calls. This separation keeps everything clean and secure. You never want to expose API keys in frontend code. Setting up project structure with Vite for React frontend and Express for Node.js backend. Installing essential dependencies, Axios for HTTP requests, Lucid React for icons, Tailwind for styling, Express for server, Course for cross-origin requests, Doten for environment variables, OpenAI for GPT-4 integration, and Nodemon for development auto-reload. This creates a clean separation between frontend and backend. Now here's the critical part, we need to configure our environment variables. Never, and I mean never, hardcode your API keys into your code. Create a .env file in your server folder and add your OpenAI and DID API keys. Add this file to .gitignore immediately. Trust me, you don't want to accidentally push your keys to GitHub and wake up to a $1,000 bill. Let's create our environment configuration. This file will load all our secret keys safely from the environment variables we just set up. We're using Doten to handle this automatically. Creating environment configuration file that uses Doten to load API keys securely. The config object exports three values, OpenAI API key for GPT-4 access, DID API key for video generation, and port for server configuration with default fallback to 3001. Including .env.example file as template for users. Now for the exciting part, let's build our Express server. This will handle all our API routes. We need CRS enabled so our frontend can talk to the backend, and we'll create two main endpoints, one for generating scripts with OpenAI, and another for creating videos with DID. Setting up Express server with CRS middleware for cross-origin requests and Express.json for parsing JSON request bodies. Initializing OpenAI client with API key from config. Creating health check endpoint at /API/health to verify server status. Server listens on configured port, default 3001, and log startup message. This forms the foundation of our backend API. Let's test our server quickly. Open a new terminal, navigate to the server folder, and run npm start. You should see that beautiful rocket emoji telling you the server is running. If you hit any errors, double-check your package.json and make sure all dependencies installed correctly. Time to integrate OpenAI. This endpoint will take a user's topic and use GPT-4 to generate a complete video script. We're giving it specific instructions to create engaging, concise scripts perfect for short-form video content. The temperature is set to 0.7 for creative but focused output. Adding post endpoint /API/generate script that accepts a topic and request body. First validates topic exists, returning 400 error if missing. Calls OpenAI chat completions API with GPT-4 model, providing system message defining AI as viral video script writer and user message requesting script about the topic. Temperature set to 0.7 for balanced creativity. Max_tokens limited to 300 for concise output. Extracts generated script from completion response and returns as JSON. Includes error handling that logs to console and returns 500 status on failure. Here's what's happening under the hood. When you hit this endpoint with a topic, it sends a request to OpenAI servers. GPT-4 processes your prompt using its massive language model, generates a tailored script, and sends it back. The whole process takes just 2-3 seconds. Pretty wild that we're literally calling one of the most advanced AIs on the planet with just a few lines of code. Now for the video generation magic with DID. This is where things get really cool. We'll send the script to DID's API along with an avatar configuration. DID will generate a realistic AI video with the avatar speaking your script. This is the same tech used by major content creators. Adding post endpoint /API /generate video that accepts script in request body. Validates script exists. Makes post request to DID API at https://api.did.com/talks with payload containing script object, text type, user script, Microsoft voice provider with NUS Jenny neural voice, config object enabling fluent speech with no audio padding, and source_URL pointing to default DID presenter avatar image. Sets authorization header with basic auth using did API key from config and content type header for JSON. Extracts talk ID from response and returns it with processing status. Includes comprehensive error handling. DID processes videos asynchronously, so we need a way to check if the video is ready. This polling endpoint checks the status of our video generation. When it's done, DID returns a URL to download the finished video. We'll call this endpoint repeatedly from the frontend until we get our video. Adding get endpoint /API /video status /talk ID that accepts talk ID as URL parameter. Makes get request to DID API to check status of video generation job. Extracts talk ID from request params and includes it in API URL path. Sets authorization header with did API key. Destructures status and result_URL from DID response. Returns JSON with current status and video URL, only populated when status equals done, otherwise null. This enables polling mechanism where frontend can repeatedly call this endpoint until video generation completes. Includes error handling for failed status checks. And that's our backend complete. 3 endpoints working together, one generates the script, another starts video creation, and the third checks when it's ready. This architecture is solid, scalable, and follows best practices. Now let's build the frontend that brings it all together. Let's build our React frontend. First, we'll set up Tailwind CSS properly. This configuration enables all the utility classes we need for our modern, responsive design. Open your Tailwind config and update it to scan all JSX files. Configuring Tailwind CSS by specifying content paths to scan for class names in index.html and all JS/JSX files in src directory. Extending theme with custom colors, primary is indigo, #6366F1, and secondary is purple, #8B5CF6, for consistent brand colors throughout app. In index.css, importing Tailwind's base styles, component classes, and utility classes using it Tailwind directives. This setup enables full Tailwind functionality with custom color palette. Now let's create our main app component. This is where all the magic happens. We'll manage state for the topic input, generated script, video processing status, and the final video URL. We're using React hooks to keep everything clean and functional. Creating main app component with necessary imports, use state from React for state management, Axios for API calls, Lookout icons, sparkles, video, download, loader, for UI. Defining API_URL constant pointing to localhost 3001 backend. Setting up state variables, topic for user input, script for generated text, video URL for final video, loading for processing state, and status for user feedback messages. Rendering container with gradient background using Tailwind classes, gradient from indigo through purple to pink, centered max width layout, and main heading. Component structure ready for adding input and video display components. Let's add the core functionality. The generate script function calls our OpenAI endpoint, then automatically triggers video generation. The pull video status function checks every 3 seconds if the video is ready. This creates a smooth, automated workflow from topic to finished video. Adding generate script async function that orchestrates entire video creation workflow. First validates topic is not empty, showing error status if blank. Sets loading state to true and clears previous script and video URL. Makes post request to /API/generate script endpoint with topic. Receives generated script and updates script state and status. Here's the polling mechanism. It keeps checking the video status until DID finishes processing. Once done, we get the video URL and display it. The 3-second interval prevents hammering the API while keeping the user experience smooth. Adding poll video status function that implements recursive polling mechanism. Defines inner check status async function that makes get request to /API/video status /talk ID endpoint. Destructures video status and URL from response. Checks 3 conditions. 1. If status is done and URL exists, sets video URL state, updates status to success message, and stops loading. 2. If status is error, displays error message and stops loading. 3. Otherwise displays current processing status and schedules another check after 3000 milliseconds, 3 seconds, using set timeout recursion. This creates a polling loop that continues until video is complete or fails. Includes error handling for network failures. Initiates polling by calling check status immediately. Now let's build the UI components. We'll create a beautiful input section with a gradient button, a script display area, and a video player. Everything is responsive and follows modern design principles with Tailwind. Building main UI with gradient background container and centered content. Title section includes video icon from Lucid React and large heading text. Input section card has white background with rounded corners and shadow. Label prompts user with emoji. Controlled input field binds to topic state via value and on change, includes placeholder text with examples, styled with border and focus states, disabled during loading. Generate button spans full width with gradient background, indigo to purple, conditionally renders loader icon with spin animation during loading or sparkles icon when ready, text changes between generating. And generate video, disabled state reduces opacity, includes hover effects and transitions for polish. Let's add the status display and script viewer. The status updates in real time as the video generates, and the script appears in a clean, readable format once generated. This keeps users informed throughout the entire process. Adding conditional status display that renders white card with rounded corners when status state exists, showing current status message in centered, medium weight text. Script display section conditionally renders when script state has content. Creates card with heading including document emoji and generated script text. Script content appears in nested gray background container with padding and border, text styled with gray color, relaxed line height for readability, and whitespace pre-wrap to preserve formatting from API response. Both sections use consistent card styling with shadows and rounded corners for visual hierarchy. Finally, the video player with download functionality. When the video is ready, it displays in a beautiful player with controls. Users can watch it directly or download it for their own use. This completes our full-featured AI video generator. Adding video display section that conditionally renders when video URL state exists. Creates card with heading including film emoji. Video element uses video URL as source, includes native controls for play/pause/volume, styled with rounded corners and shadow, takes full width of container. Download link wraps entire button, uses video URL as ref, sets download attribute with default file name AI generated video.mp4, styled as gradient button, green to emerald, with download icon from Lucid React, includes hover effects. Closing all component divs and exporting app as default. This completes the full React component with all functionality, input, script generation, video creation, status updates, and video playback with download. Let's see it in action. Start both the backend and frontend servers. Type in a topic like the future of AI and hit generate. Watch as the AI writes a script in seconds, then DID creates a professional video with a realistic avatar. In under a minute, you've got a shareable video. This is the power of combining multiple AI services. How to deploy your app. Ready to share your creation with the world? Deploy the frontend to Vercel or Netlify, both offer free hosting and automatic deployments from GitHub. For the backend, use Railway, Render, or Heroku. Don't forget to set your environment variables in the deployment dashboard. Update your frontend API URL to point to your deployed backend. And boom, you've got a live AI video generator anyone can use. Ideas to enhance your project. Want to take this further? Add user authentication so people can save their videos. Implement a credit system for monetization. Add multiple avatar options and voice selections. Include text overlay capabilities. Create video templates for different niches. Add social media auto-posting. The possibilities are endless, this is just the foundation. And there you have it, a fully functional AI video generator built in 30 minutes. You've integrated cutting-edge AI APIs, built a clean React frontend, and created something that actually works. The best part? You can customize this, add features, and even turn it into a business. I've seen people charge for tools exactly like this. So what are you waiting for? Start building, start experimenting, and who knows, your project might be the next viral AI tool.